Hello everyone, welcome to the problem solving session. So problem solving session on diffusion in multi-component in solids. So this is seventh week that we are carrying out this problem solving sessions, and this will be useful. This session will be useful for solving the and clearing the doubts regarding with the concept that covers in the previous weeks. So if you have any doubts, please let me know, or otherwise if I'm able to solve it, I will solve here itself. Otherwise I will work out and let you in the next problem solving session, or I will mail you to the given mail id. And this week, so this is a week 7 that we are carrying out this problem solving session. So week 7 is from lecture 28 to 29, 28 to 32, in which these are the topics that we been have been covered till now. First, it is started with energetics of vacancy formation, and the next lecture is experimental determination of enthalpy of vacancy formation, mechanism of diffusion in metals and alloys, and point defects in intermetallics and the ionic compounds, a diffusion mechanism in intermetallics. These are the some basic some concepts are covered in the week 7. In energetic formation, how these vacancies are formed, and if the vacancies are from the innermost crystal, as atom is removed and it is placed onto the surface of free surfaces, there is how much bonds, how much energy is required, and how much energy is required to break the neighboring bonds, and what is the formation of enthalpy of formation of energy, is the entropy increases or decreases by forming the vacancies. Everything is discussed in this lecture 28. Whereas experimental determination of the enthalpy of vacancy formation, different methods have been used till now for determining the enthalpy of formation of vacancy formation, enthalpy of vacancy formation. For example, positron annihilation, in which isotropic radioactive sodium isotope is been exposed to the materials. It will emit the gamma radiations, and these gamma radiations take a longer duration of time if the vacancies are in more quantity. That means the lifespan of a gamma radiation is directly proportional to the vacancies. That So this is the way in which we can determine the enthalpy of vacancy formation. And the mechanism of diffusion mechanism of diffusion in the metals and alloys, different mechanisms. For example, vacancy mechanism, or substitution mechanisms, different mechanism are explained in the lecture 30. And whereas in the lecture 31st, point effects in the intermetallics and ionic compounds, anticides, Frankel defect, Schottky defect. So the brief introduction of these defects are explained in the lecture 31. Whereas in lecture 32, diffusion mechanism intermetallics having the ordered structure, so that's why they have different type of diffusion mechanism, like double NJ, next nearest nearest neighbor jump, triple NJ, next to nearest neighbor jumps, then the SJVC model, six SJVC model, and so on are explained in the lecture 32. So after this, we will getting into the problems. Problem 1. The problem 1 saying that the equilibrium concentration of a mono vacancies in a metal is measured to be 1.5 into 10 to the power of 15 per meter cube at 600 Kelvin. If the temperature is increases to 800 Kelvin, the concentration of mono vacancies are T into 10 power of 15 per meter cube. So what is the approximate values of the enthalpy of formation of mono vacancies? So he is asking about the enthalpy of formation of the mono vacancies. This is the enthalpy of formation of the mono vacancy. If he is at T1 600 Kelvin, so this is the vacancy concentration at 800 Kelvin, and it is doubled. Since the temperature is not doubled, but if temperature is only 200 Kelvin is increased, and the vacancy concentration is doubled. This is indicates that the temperature has an exponential effect on the enthalpy concentration of vacancy concentrations. So this is the equation that we have been used for determining the enthalpy of formation of mono vacancies. H1V is equals to exponential of minus delta H1V divided by KT. For two different temperature, we have equation 1 and equation 2. Okay, so by solving these two, we can get the H1V. Right? Yes. Have you got the answer for this one? Please try. It's a simple mathematics is there. Okay, so I think you got the answer for this one. Let's move to the next problem. So activation energy for the diffusion of a carbon in a chromium is 111 111 joules per mole. Calculate the diffusion coefficient at 1100 Kelvin given that D at 1400 Kelvin is this one. So let's write the first given. So we'll get some marks for writing the given. So we this is heard from the since from we are in childhood. When we are write the board exam, we have to write the given. Similarly, we have to write the not only for the marks purpose, but also clear understanding of the problem also. So activation energy is Q is equals to joules per mole, and the calculate the diffusion coefficient at 1100 Kelvin. So need to calculate the T1 1100 Kelvin. So we need to calculate the D value, but also one more thing he has given is D value. D1 need to calculate. D2 he has given, that is 6.25 into 10 to the power of minus 11, that to T2 given as 1400 Kelvin. So to solve this question, we need a question, we need a equation. Write the first equation. D is equals to D naught into exponential of minus delta H, sorry, QD divided by R into T. K into T, right? So for in this equation, to determine the D value at 1100, so what are the things he has given? First I will write clearly. This is QD. Okay, so what are the thing he has given? First, QD, he has given QD, yes. Temperature he has given, yes. D naught he has not given, and D we need to calculate. To calculate the D naught, we can use the other equation, other given thing, that is T2 equal to D naught into exponential of minus QD divided by K into T2, right? So I'm just substituting the values. 6.25 into 10 to the power of minus 11 D naught exponential of minus, this is 111,000 divided by K into T2. T2 is, we know, 1400. So get the value of D naught here. So after that, you just substitute the value of D naught exponential of minus 111,000 divided by K into this at 1100 Kelvin. So from here you can calculate the d value directly. Just calculate for this. Okay. We will move to the next problem. The pre-exponential and the activation energy for the diffusion of a iron in a cobalt are given here. Okay, so this one and this one is both given respectively. At what temperature will the diffusion coefficient have a value of this? You need to ask. So let's write a given. So pre-exponential and activation energy. Pre-exponential means d naught 1.1 into 10 to the power of minus 5, and activation energy q d q naught 2253300. It's like mobile number, right? Meter square per second, joules per mole. So here also given the d value 2.1 into 10 to the power of minus 4 meter square per second, and one more you need to calculate the set to calculate t value. So similarly, from the previous problem itself, we got same, we used the same equation, exponential of qd divided by k into t. So use this equation, substitute the value of d 2.1 into 10 to the power of minus 4, d naught 1.1 into 10 to the power of minus 5, exponential of minus 2.5 into 10 to the power of 5, 2.53 k into, you need to calculate the t value. So you just need to calculate the t here by taking divide it and take a natural log of this one and get the value for the t in Kelvin. So this is how. So these are the three problems that we are solved in this week, and we will be meeting next. So we will be getting more problems of this kind next week. Thank you.